Hello, nonlinear algebra. This is a lecture on factoring of the form x squared plus bx plus c. This is one of the most pivotal lessons that we will do all year. It's going to be very important that you guys put on your thinking caps and really struggle through this with me, as, like I said, this is going to be a really critical section as you move forward. So from section 8.4, we know that we can factor a polynomial like x squared plus 9x equals 0. And when we factor it, we can actually solve that equation. We look here and we say, okay, both of those have an x in common, and that is the GCF. So I could factor that out front by essentially undoing the distributive property, right? X is the greatest thing they have in common. That can go in front of their parentheses. And then I ask x times what is x squared, and x times what is 9x. That would be a plus 9. And in a sense, we've undone the distributive property. We could redo it if we wanted to. Get back up here. We don't want to, of course. Instead, we want to use the zero product property, which states that if you have something and you multiply it by something else, and the answer is 0, then either this must have been 0 or this must have been 0. So then the question becomes, well, what makes this 0? And that would be 0. And what makes this 0? That would be negative 9. Now, you might have noticed that every one of your answers in section 8.4, one of the answers was 0, and then another answer was some other number. That is because every term had an x in it before. But in today's lesson, we're going to be factoring things that look like this, where it's x squared, like we had, and then a bx, like we had, but there's also going to be this plus c at the end. And 0 is no longer going to be a solution, and the process is going to be a little bit more involved than this. Let's take a look at an example of what we're going to be doing. We're going to be solving equations that look like this. You guys see the difference? Now there's a plus 14. 0 doesn't actually work. If you plugged in 0 here, yes, it equals 0. 0 plus 0 is 0. But if you plugged in here, 0 here would be 0 plus 0 plus 14. That's 14. That does not equal 0. So this is the goal for today. And like I said, super important section as we move forward. A prerequisite skill, something you already need to know in order to be able to accomplish the task today, would be we need to know how to FOIL x plus 7 times x plus 2. Let's do a quick review on this. First, we would multiply the first two together, and we would get x squared. Then we'd multiply the outside two together, and we would get plus 2x. Up next, we'd multiply the inside ones together, plus 7x. And then the last two, and 7 times 2 is 14. From here, we could combine like terms, and we do have a couple of like terms. So we'd have x squared plus 9x plus 14. So foiling, really important process. It's going from this equation to this equation. In today's topic, factoring, that is going from this guy here, x squared plus 9x plus 14, back up to the factored expression that's called before we FOILed it. So this process going from here to here is called FOILing. And this process going from this statement back up to here is called factoring. It's going to be a really important section. So let's ask ourselves some questions. If I were to give you this and expect you to come up with this, the question you need to ask yourself is, how did the numbers 2 and 7 get us to 14 and 9? So we had 2 and 7 here. And down below, we had 14 and 9. And 7 and 2 happen to be two numbers that get us to 14 and 9 in different ways. When you multiply these two things together, you get 14. And when you add these things together, you get 9. Let's look at another example of this. Let's see if it still works. So if I ask you guys to FOIL this, we should know how to do that really easily. We'd first times first, x squared. Outside times outside would give us plus 3x. Inside times inside would give us minus 5x. And last times last would give us minus 15. We can combine some, and we would get x squared minus 2x minus 15. So as we start to think about how in the world we're going to go from here to here, let's take a look at, again, the numbers that we need to come up with are -5 and 3. Is there a way that you could look at this and come up with -5 and +3. Well, what do these things multiply to? -15. What do they add to? -2. And we're going to be using that in a kind of a systematic way to answer these problems. So we're going to be given a statement that looks like this. And we're going to be turning it into this. And that's called factoring. Here's the thing that makes it work. P and Q are going to add to the middle term, and P and Q are going to multiply to the last term. That's how this is going to work. What's going to be the process? First, you're going to list the factors of C. So this is what our polynomial will look like. You're going to start out by listing the factors of C. List them in pairs. Then you're going to look for which set of factors add to the middle term, which is B. And those factors are going to be P and Q, and you're going to write those in, and X will just be X. We have 6 examples of this, and then we're going to be done today. So our first example, the process that I wrote up there said, first list the factors of C. 4 is our C term. Let's list the factors of 4. I like to just do this right here, right underneath it. 1 and 4 multiplies to 4. And so does 2 and 2. Those are the only factors of 4. Step 2 said to pick which set of factors could get you to the middle term, which is 5. Well, 2 and 2 never add to 5, but 1 and 4 do, right? If both the 1 was positive and the 4 was positive, then it would add to 5. And +1 and +4 multiply to 4. So our answer is going to be X plus 1 and X plus 4. Boom. Let's try it again. Same idea. You're going to go to the C term and list the factors of the C term, which in this case is 21. There are not very many factors of 21, just 1 and 21 and 3 and 7. Which of these factor pairs add to 10 and how? Well, if the 3 was positive and the 7 was positive, they would add to 10 and multiply to 21. X plus 3, X plus 7. Now, a really good question here is, does it matter if I switch the order of these? No, it doesn't. It's the exact same thing to say X plus 7 and X plus 3. Either one of these are the answers that would be acceptable. Go ahead and pause here. Make sure you guys know what you're doing. Try this one out. I'm going to go ahead and list the factor pairs of 20, 1 and 20, 2 and 10, 4 and 5. Which of these factor pairs add to +9 and how +4 and +5 does? So answer X plus 4, X plus 5. That was 3 examples. We have 3 more. Now we're going to start to work with some negatives, which is just fine. Same exact process. Start with 32. List the factors of 32. I come up with 1 and 32. I've got 2 and 16. 3 doesn't, but 4 does. 4 and 8. 5 doesn't, and 6 doesn't. So it's got to be one of those, if it's factorable. 1 and 32 could never add to -12. 2 and 16 could never add to -12. But 4 and 8 could. If the 4 was negative and the 8 was negative, then these two things multiply to 32 and add to -12. So it would be X minus 4 and X minus 8. Answer. Remember, you guys get to pick the signs. Same idea here. What multiplies to 15? 1 and 15. 3 and 5. Could 3 and 5 ever get you to -8? Yes, sure. If the 3 was negative and the 5 was negative. X minus 3, X minus 5. I'm actually going to have you do the next 2 on your own. No, one of them is going to be this one, and I'm going to add one more, and then we'll be done. I'm going to add X squared minus 24 plus 2X. So try both of those 2. See how you do. The factors of 9 would be 1 and 9 and 3 and 3. How could 1 and 9 or 3 and 3 get you to -6? Well, if they are both negative, then they add to negative 6 and multiply to positive 9, x minus 3, and x minus 3. Same idea here with this last one. Factors of 24 would be 1 and 24, 2 and 12, 3 and 8, and 4 and 6. Now we need one of these pairs of numbers to add to positive 2. And 1 and 24 never could, 2 and 12 never could, 3 and 8 never could. But if the 4 was negative and the 6 was positive, then these two things would add to positive 2. So in factored form, x minus 4 and x plus 6. Please let me know if you guys have any questions, and I'll see you around.